notice, and this is the typical copyright. Mathematics syllabus, effective May-June 2018. Note that generally CSEC revises its syllabus every 10 years. So this syllabus should actually run from May-June 2018 to May-June 2027. However, as of December 2025, this syllabus has not been revised, but there are plans to change the structure of the exam from 2028 and onward. And right now, there are a few pilot projects being conducted in a few Caribbean countries. The major changes will be to split the exam into two parts. So as a one certification, you'll have a part 1 and a part 2. And 2, structure questions from paper 2 will be required from all previous alternative sections. So now you would be tested on everything in the syllabus. As you already know, sections 1, 2, and 3, those were all completed and published in their entirety. So please make good use of them. They are published on YouTube. And then section 4, measurement, 17 videos, 5 have been published in their entirety on YouTube. Section 5, statistics, out of the 18 videos from that section, 5 have been published in their entirety on YouTube. Algebra, out of those 22 videos, 7 have been published in their entirety on YouTube. It did take some time to set up the online school, so the need arises to reschedule the last 3 parts. So now we are at section 7. This is the first of 26 videos, and it hopefully should all be finished by February 2026. After that, section 8, geometry, by March 2026. And finally, section 9, vectors and matrices, by April-May 2026. Disclaimer down here, please note that this schedule is just a projection and it is not a contract with anybody. From section 1, as I said before, all 33 of these videos have been published in their entirety on YouTube, since they form the foundation on which the rest of the math syllabus is based. Another reminder is that you need to know the times tables from 2 to 12, especially since calculators are not allowed or permitted in paper 1. This is section 2. All of those videos, as I said, have been published on YouTube in their entirety. Section 3, sets. All of these 6 videos have been published on YouTube in their entirety. From section 4, these are the ones that have been published in their entirety on YouTube. The others are only partially published. Please see directions in the description below if you need to access the full videos that are only partially published here. From section 5, statistics, these are published in their entirety on YouTube that you see here indicated in yellow, and the others are only partially published on YouTube. Again, please see directions in the description below if you would like to access those videos in their entirety. Section 6, algebra, same principle applies here. These are published in their entirety on YouTube, and the others only partially published. Again, please see directions in the description below for full access to these videos that are only partially published on YouTube. Section 7, we are here now. This section has 26 videos, as you could see. Before we go on, recall I said in the introductory video that you will need a good math textbook or a set of two to get more practice questions, especially. CSEC recommends the following, shown at right here. From those, please pay close attention to these last two down here, especially since these two form a very good two-volume set of math textbooks that is quite adequate for the current CSEC math exam. This is a picture of Volume 1, Mathematics, a complete course with CSEC questions. Well, it says here with CXC questions, Volume 1. And then the same thing for Volume 2 with CXC questions at the CSEC level. Disclaimer, I get no financial or other benefits from the sale of these books that you see up here. Also, as of late 2024, a website with AI interactivity has been made available free of cost that deals with past CSEC math questions only. You can navigate by topics or years, where all questions for the past several years have been worked out for you. If you have a question that you still need explained, you can ask the AI assistant either by text or voice, and most likely it will be explained to you. It is extremely important that you become familiar with how CSEC sets its questions for paper 2 and what will be considered good or correct answers to such questions. This is the URL for that website, RSC homepage, and I will show you what the homepage looks like on the next slide. This is the homepage. You will have to sign up. That's the website again. The URL will be in the description of this video below, so all you will need to do is click on it if you want to get to this website. Another reminder, this is the formula sheet that is provided for CSEC math examination papers. That's the complete formula sheet. There will be a link in the description below from where you can download this formula sheet. Just a closer look. This is the top part of that formula sheet. Note that you do not need to memorize these formulae on this formula sheet, as this sheet will be provided during the examination. And this is the below part of that same formula sheet. While you do not need to memorize these formulae, you do need to know when and how to use them. So we are at section 7, relations, functions, and graphs. This is a print screen from the syllabus. We, of course, will begin at objective 1. And this is the rest of the syllabus, just for you to get a preview. Up to objective 9, print screen again. Up to objective 13, print screen from your syllabus. To objective 17, print screen from your syllabus. Then up to objective 20, again, print screen from your syllabus. Continuing, objective 22, print screen from your syllabus. We will deal with each of these in detail. And then finally, up to objective 26, again, this is a print screen. And this will bring us to the end of section 7, relations, functions, and graphs. So we are here. Objective 7.1, section 7. When this is finished, it will be published in its entirety. And we would have to go up to video 26 for this section. Objective 1, it says, explain basic concepts associated with relations. And there are some explanatory notes here. The concept of relation, types of relations, examples of relation, and non-examples of relation. That non-example situation there may be a little difficult to understand. Domain, range, image, and codomain. So those are the things we will be looking at as an introduction to this section. Now, the concept of relation. First of all, let's talk about domain, range, and then we will talk about codomain and image. Firstly, we will begin with definitions given in your syllabus. Domain of the function f is the set of object x for which f of x is defined. And secondly, range of function f is the set of all numbers f of x for x in the domain of f. Okay. These are the only two definitions given in the glossary of the CSEC syllabus. And they are a bit confusing or difficult to understand, especially if you don't already know something about relations and functions. But as time goes by, we will understand them better. In mathematics, a relation is any connection between elements of two or more sets formally defined as a set of ordered pairs. These pairs link elements from the first set, which is called the domain, to elements of the second set, which is called the codomain. And those particular elements are called the range. Any element from the domain is called an input, and the corresponding element from the codomain in the ordered pair is called the output. Do not confuse codomain with range, as only elements that are outputs make up the range. So let's consider the domain Q that has these numbers 1 to 4, and the codomain N that has these letters. Now, if there is a one-to-one connection, as you see here, 1 connecting to A, that's an ordered pair, 2 connecting to B, and so on, those are other ordered pairs. In this case, you may also have another domain and codomain, similar, except now you don't have all the elements from domain Q connecting with codomain N. You may have something like that, where you only have these two ordered pairs. But remember, we are looking at domain and codomain. What do we mean by that? And thirdly, we have a domain Q and codomain N, as we were looking at all along the line. In this case, you may have a connection like that, with the pair is 1A, another one like that, 1B, another one like this, 3C, and that will be all the connections. So you get the idea that there is a domain, which is an independent variable, and any element from the domain may be connected to elements from the codomain. Now, only those elements chosen or linked in the codomain would be range, as we shall see shortly. But before we get to that, let's talk about types of relations. These are based on the linking of elements of a set with elements of another set, or with its own elements. Now, since CSEC did not specify how many of these we need to know about, I will just list them for your information and then move on to the few that CSEC actually uses. Well, you look at this and it's starting to look very confusing. Types of relations. We have 8 of them listed here. I will briefly mention a few things about them. You have the empty relation. So you have two groups, a domain and a codomain, but there is no element from the domain related to any other element from the codomain or from itself. That will be considered an empty relation. And I think that is what CSEC means here by non-examples of relations. That's what I think. Then you have the universal relation. Every element of set Q is related to every element of set N. Now, that's pretty easy to understand. Then you have the identity relation. It contains only the ordered pairs where every element of set Q is related only to itself, not to N. You also have the reflexive relation, where every element of Q is related to every element of itself. The difference between reflexive relation and identity relation is that in the identity relation, it should contain only ordered pairs in the form 1, 1, 2, 2, 3, 3, and so on. Whereas in reflexive relation, it may also contain any other ordered pairs within that one set, like 1, 2, 1, 3, and so on. Then you have symmetric relation. Now, I am not going to go through the explanation here. All I'm going to say is a real life example of this is if John is a brother of Sam, then Sam can also be considered a brother of John. Symmetric. From A to B is the same from B to A. Then there is transitive relation. Now, this one is like a go-between. For example, if P, Q, and R are three persons such that P is a friend of Q, Q is a friend of R, then P is said to be a friend of R. So it's transitive where there is like a go-between two other groups. Then you have equivalence relation, and this one is a little harder to understand because this one is an example that takes in all these three. I'm not going to explain it. I'm just putting it here for your information. After that, there is antisymmetric relation. And this goes like this. If you have a relation R that is made up of the subset A and B, such that A is less than or equal to B, and also you have the opposite of that, where B is less than or equal to A, then A is equal to B. So it's antisymmetric. It's like, it's not this, but it's not that, so it's the one in between. And then you have the inverse relation. Now, this is the one that you have to know for CSEC. And it is denoted by R with a -1 to it. So example 1, if you have 1, 2, 3, 5, and 7, 5, 7, then you exchange these. So now you have 2, 1, 5, 3, and 7, 5. As I said, I don't think CSEC requires you to know these concepts, except maybe 9 in detail. They were just listed here so you will have an idea how involved and complex the matter of relations can become. Now, if you find this video useful and interesting, please like and share. That is to say, like and share. You may also consider subscribing to this channel. As I said before, in mathematics, a relation is any connection between elements of two or more sets formally defined as a set of ordered pairs. These pairs link elements from the first set, and the first set is called the domain, with elements of the second set, which is called the co-domain. Now let's straighten out this matter about range. Do not confuse codomain with range, as only elements that are outputs make up the range. So let's consider domain Q and domain N. If these are linked like that, then you will notice that the range is the whole codomain, because all the elements from the codomain is used. So in this case, the range and the codomain are the same. Let's look at this example. You have the domain and the codomain, and now we have these. Notice from the codomain, those are used, only A and D. So from the codomain, the range is A and D, and it is not the whole codomain as we had over here. And to further strengthen that point, let's look at the same domain and codomain, but different connections. Now, in this case, this is the domain. Everything here, whether it is used or not. The codomain, this is the codomain. Everything here, whether we use them or not. However, the range is only those members of the codomain that are linked to anything from the domain. So in this case, the range is A, B, and C, and it is not the same as the codomain. So hopefully we have that matter straightened out. Domain, codomain, and range. We have seen this before. The range is the same as the codomain because every element in the codomain is used. Here, the range is different from the codomain. Only those elements that are used from the codomain are considered as range. And over on this side, same principle applies. This is the domain. This over here is the codomain, but only those elements from the codomain that are linked to something from the domain will be considered the range. So range here is A, B, C. So please do not confuse codomain and range. The domain, of course, is the independent set of elements. Normally you would see this on the left-hand side of an arrangement like. Just to ensure that you understand these four concepts, because you have to understand them for the rest of this section. Let us say we have a relation here. Now this is a relation. Y is equal to 2x plus 1. It's in the form of an equation. The domain would be the independent variables for x. Let us say it is from -5 to 5. That's the domain. It is the independent set of elements, integers from 5 to -5. The codomain is the integers from 15 to -15. It includes numbers that we will not be connected to via this relationship. So that's the codomain. The range are those elements from the codomain that are mapped onto elements of the domain under a given relationship. So this is a relationship. When we work that out, 1 maps into 3, 4 maps into 9. That is to say, 2 times 4 plus 1 would give us 9, and so on. So that's the relation. This is the domain, codomain. Elements from the codomain that are mapped to the domain are called the range. Image now, which is a different concept, refers to only that part of the range as specified by a subset of the domain. So let's get this quite clear. The range is part of the codomain. It could be the whole codomain or part of it. That's a range. Image is part of the range. So let's look at the image of A, which is this 2 here. What is it linked to? To 5. So as far as we are concerned, that is the image of A, which is 2. And if we look at the image of B, which is 2 and 5, that will be this 2 here and that 5 there, then those images would be 5 and 11. This 5 here and that 11 there. Now, there are 4 common types of relations that you especially need to know for CSEC mathematics exam. One is called one-to-one, indicated like that. Another one is called one to many, indicated like that, a third, many to one, and a fourth, many to many. Those are the four types of relations that we need to know, especially for CSEC, irrespective of all those other relations we looked at the beginning of this video. So one-to-one is fairly simple, where one element from the domain is connected or linked to one element from the codomain, like that, one-to-one, as you can clearly see. Next one is one to many. So one from the domain is connected to many from the codomain. So you may have this one connected to A, B, and C here, or you may have four, that one connected to C, D, and E. That's one to many. And then the next one is many to one. So you may have this here, 1, 2, and 3 linked to just B, or 4 and 5 linked to just D. This is fairly easy to understand. And lastly, many to many. So you have this one here connected to many, or you may have these many here, 2, 3, and 4 connected to one or linked to one. So those are the basic four types of relations that we need to know about for CSEC. Now, we are going to go a little step further. We will not use this right now, but we will need it as we continue. Now, in which of these relations does an element of the domain map onto only one element of the codomain? Which of these? And obviously, you could see this one here, this one here, this one here, no, you have one mapped to more than one. This one here, yes. This one is mapped to B, this 2 is mapped to B, this 3 is mapped to B. So one from the domain is mapped onto only one from the codomain. And of course, this one here, no. Now, there is a special relation between this one on the far left here and this one here. One-to-one and many-to-one are called functions. They are special types of relation. We will not use this per se in this video, but we will use it as we go along, maybe the next video and the next one and so on. So those two, they are relation, but they are special types of relations, and those relations are called functions. Now, a function is a restriction on a relation, such that any function is also a relation, but only some relations are functions. Specifically, a function can have no more than one output for any given input. However, a relation may have many outputs for a given input. For example, if X is an input and Y is an output, then Y is equal to mx plus B is a function, since for every X input you would get only one Y output, only one. But if you take another relation like this, X is equal to Y squared, this is not a function, because if you take, for example, 9 for X, you find that Y could be 3 or negative 3. So you have two outputs. In its simplest term, a relation is defined as a set of ordered pairs that obey a particular rule. As I said, do not become confused with relation and function. A function is defined as a relation in which each element of the domain is mapped onto one and only one element of the range. So a function is a subset of a relation. If in this ellipse here, we have all relation, then function is a subset of relation. If, as we said, a relation in mathematics is a connection between the elements of two or more sets formally defined as a set of ordered pairs, then what would be non-relation? Now, thus far, we already talked about codomain, image, range, domain, examples of relations, types of relations, concept of relation. The only thing that remains would be non-examples of relations. And as I indicated before, this is much more difficult than you would think. In mathematics, a non-relation generally refers to a set of ordered pairs, we still have ordered pairs, that do not satisfy specific properties required to be classified as a particular type of relation, such as reflexive, symmetric, or transitive, or even a function. So as I said, this could get complicated. So just for this class, we will say that non-relations would be two groups of elements that are not any one of these four. They are not one-to-one, one-to-many, many-to-one, or many-to-many. It could become complicated, so we will just leave that as it is there. And as we go along, we will learn more about this. And that should suffice for this introductory objective, where it says explain basic concepts associated with relations. We talked about concept of relation, types of relations, examples of relations, and we had some little problem with non-examples, domain, range, image, and codomain. And that brings us to the end of video 1 based on objective 1 in section 7.